Stop sharing. Let me share again. Don't know what's happening now. Okay. Okay. All right. So we're gonna start with this Fourier series. The most important techniques that we really need to master, I believe, in order for us to understand this topic, which is called the Fourier expansion series. And how the questions are being asked, that's also very important because the questions can be asked in different ways. So we need to pay attention into some few details over there and know how to go about by solving those questions. Like for example, we have Fourier series in half range, and then we have Fourier series, which will be represented in non-half ranges. So we need to know how to go about for such type of equations, also for such type of problems. So now the first question that we're going to start with is this one. Without wasting time, we are provided with the first question. So like I said, it's important by just looking at the question, you should be able to know where to start, what are you going to do, and what are the things that you need to pay attention on to. So now when we are given a function like this, we have a piecewise function, which is 0 and 3. And then we are also given the restriction for this function that t, which is our independent variable, it exists between -5 and 0. And therefore, we are also given the function which is t, whereby the independent variable in this case, which is t, it exists within this interval, which is between 5 and 0. And also, we are provided with what? We are provided with the period. Having a look at this equation, we will be able to determine the period of this piecewise function. Now, what is the question? The question says to us, determine the Fourier series. When question comes to you just like this and says to you, determine the Fourier series, the first thing that you need to do, by just looking at the function, you can tell that in this case, this is not a half-range period. So when you're given a function like this, you're not going to look at it in a form of whether it's, you're going to first look at it, whether this function, it is odd, it is even, or it is neither. If it is neither, then B sub naught and A sub naught will be equals to a certain value. But we know that when we are focusing on even function, we'll be looking at B sub naught and A sub naught. When we are focusing on odd functions, again, we'll be looking at A sub naught and B sub naught. Okay, because I don't want to confuse you, it's fine. Let us solve this question so that we can jump to the other examples and see how these questions actually go out. Now, in this question, this is a straight Fourier series. By looking at this function, I am saying to you, this function, it is neither odd, it is neither even. Remember, you should be able to know how to draw the cycles of this function. You should be able to know how to determine whether the function it is odd or the function it is neither, right? You should be able to know how to determine all of those things. So now what I'm doing is I'm just taking it only from the Fourier series, okay? I'm just taking it from the Fourier series. But by looking at this function, if we were to draw this function on a Cartesian plane, you will see that this function is going to be neither. It's not going to be odd or even. So if that is the case, then we're going to have to determine B sub naught and A sub naught. Okay, B sub n and A sub n. So, okay, how are we going to do this? Now, this is what we are going to do. The first thing is, let us determine all of the properties that we need. Let's talk about the period of this function. I say the period of this function, we're going to take it from here. And then in this case, period, it is given by what? It is actually given by t, right? So now to determine the period of this function, we're going to say it is 10. We look at it from here, which is t. We look at this number over here. We're going to say period of the function is equals to 2L. We always use L all the time, or we always use 2L all the times when we equate period, when we form this equation that has period in it. So the period of this function, like I said, it's going to be how much? It's going to 10. So that means here we're going to have 10, which will be equals to 2L. Now this L, our upper and lower bounds. Therefore, when we divide both sides by 2, we can see that our value of L in this case will be equals to 5. How did I get this L? I use this equation. You should know it. So where did I get T from? I got it from this equation. What does the T stands for? It stands for our period. And then it will help us to determine the numerical value of L. So L in this case is 5. So L, it is bound and the lower bound. You will see what do I mean by saying that, okay? This is the first thing. And then the second thing that we're going to start with is because we want to determine the Fourier series. Remember, when we determine the Fourier series, the standard form is this one over here. Let's not forget. So we have f at, let's take f at t is equals to, remember, you should know this equation by yourselves. A sub naught divided by 2 plus sigma. Here we have what? We have n running. What's happening now? Pen is not okay. We have n running from 1 up to infinity, right? And therefore here we're going to have a sub n, and therefore we have cos what? Here we're going to have cos n pi t divide by our L plus sigma n running from 1 to infinity b sub n. Here we have sine now. Here we're going to have sine n pi t divide by L. So remember, this is a standard form on how an expansion will actually look like, right? So our aim over here, it is to do what? It is to determine A sub naught and to determine A sub n and to determine B sub n. So like I say, this function over here, it is neither what? It is neither odd nor even. So if the function, it is neither odd or even, therefore we're going to have to determine A sub n and B sub n. We're not going to get the 0, meaning A sub n is not equals to 0. B sub n, it is also not equals to 0 because our function, it is neither odd or nor even. So that's why we say A sub n, it is equal to something. Even A sub naught is not equals to 0. Right. So the question is, how are we going to determine these guys over here, A sub naught? To determine A sub naught, there is a special formula that we use. So we're gonna have A sub naught, which is equals to. Now this is a special, the special equation that we actually use to determine this. We say 1 over L. Hear me out. Hear me out. Hear me out. Here I'm writing 1 over L. 1 over L. Okay. Reason being, I am not working with half-ranged function. But if I'm working with half-ranged function, here I'm gonna write 2 over L. But here I'm not working with half-range function, therefore I'm writing 1 over L. Let's be careful on that one. Okay. So, and then here we have the bound, which is L, whereby we're going to have f at t, which is our function, multiplied by what? Multiplied by dt. So this is the equation that we use to determine A sub naught, which is what we are looking for over there. Now, using this over here, I know my numerical value of L, it is how much? I know that my numerical value of L, it is 5, already determined over here. So meaning here, I'm going to have 1 over 5, the integral of, now look, this is f at t, which is this function. And this function, we have it as 0, we have it as 3. So if we substitute 0 over here, everything will die. Derivative, integration of 0 is 0, everything doesn't exist. So that means I'm going to focus only on this one over here. Or you can write it like, okay, let me just write it like this. 0, so that in future you know it. 0, here we're going to have dt. Now let's talk about the bounds. So what is the upper bound and lower bound. This is the lower value, right? So the lower bound over here, it's going to be -5. So our -5, we write it over there. And therefore, the upper bound there, it's 0. We're going to write it over there because we are using our function as 0 dt, right? Plus, like I said, because we have two functions over there, you can just put bracket over there, just like so, or you can just put 1/5 again, however you want to do it. If you want to put the 1/5 here, it is still 5, or you can just put the bracket and write only 1/5. You don't have to repeat 1/5 twice. But if you don't put the bracket, just like how I'm doing it over here, you can just write it like this: 1/5. The integral of now our function is +3. We write 3 over here. And in the bounds for this one, or the limits for this one, the lower is going to be 0, and then the upper is going to be 5 dt. Right? And therefore, in this case, what's happening is this is the integration of 0, it falls out. So we are not interested in it. But here we just have a constant. So now let us determine the integral of 3. So by the way, 3 is a constant, we can take it outside. So we're going to have 3/5 over here, the integral of dt. Our lower bound is 5. Our upper bound, it is +5. Now, what is the integral of this 1 dt, meaning we're going to have to bring back t, right? So here we're going to have 3/5, and then we're going to bring back t. And therefore, we put our square bracket over there. And then our upper bound is 5, and then our lower bound here, it's going to be 0. And therefore, now what I'm going to do is I have 3/5. Remember, I substitute my bound. Here I have 5, subtract. Now I substitute 0 there. Then I'm going to have 0, close my square bracket. And therefore, when I distribute everything inside of the bracket, 5 will cancel 5. And therefore, my answer here will be 3. So that means A sub naught will be equals to 3. So we are sorted with this part over here. Now we're going to jump to this part over here, which is A sub n. Now, in order for us to determine A sub n, we're going to say A sub n, it's going to be equals to how much? Again, you need to make sure that you know all of these equations because they're not going to be given to you. Again, we're going to write 1/L, the integral of what? The integral of our function. We have the lower bound there, we have the upper bound there, then here we have the lower bound. And therefore the integral of f at t, but now we are looking for A sub n, it's not going to be the same as this one. Now this one, because it's A sub n, you can even take it from here if you still do remember this expansion. So meaning it's going to be f at t multiplied by cos of n pi t divided by L dt, right? And then now, what are we going to do from here? From here, we're going to have to integrate. But firstly, we're going to have to substitute our functions over there, which is 0 and 3. Like I said, it is not necessary for you to substitute 0 just like how I did over here. You can strictly go to 3 because you know that the integral of 0 automatically will fall off. There will be nothing over here, so I'll just take it from 3. I'm explaining it because I don't want you to get confused. Why am I not writing 0 but 3? So now here we're going to have 1/5, and then we have the integral of, because we are substituting 3 as our, do not return from here. The lower bound is going to be 0, and the upper bound is going to be +5, right? This is f at t multiplied by cos what? By cos n pi t. Remember our L, it is actually equals to 5 dt. And therefore 3, I take my 3 right of the sign, 0 there I have 5. Now integration by parts, we're going to have to use substitutions, all of those techniques that we have learned from first year, even maybe at the beginning of this year when we integrate. I'm reminding you because remember, when we integrate from unit 1, recall that you can use partial integration by parts, you can use your use substitution. It's possible, right? It depends. But normally, we've seen that we use integration by parts. So make sure that your integration technique is on point. Now here we just only have one function. We are not multiplying two functions. So now what is the integral? Of course, we know it's going to change to its core function. In this case, its core function, it will most definitely be what? It will most definitely be sine, right? So when we integrate this, we have 3 over 5, and then I'm going to put my square bracket over here. And then when we integrate this, remember, we take 5, we're going to take the reciprocal of this, which is 5 over n pi. Don't be me and make mistakes. What mistake I want you to avoid, of which people can avoid, you're going to take t. T, it is our variable. It is our independent. We are deriving in respect to t. So do not take t. Take n pi. That's a mistake that I believe you can make. So please be careful when you integrate this. And therefore, remember, cos will most definitely change to its core function, which is what? Which is sine. So that means we're going to have sine. We repeat everything as it is. N pi t divide by 5 square bracket. Our upper bound is 5 and our lower bound is 0. And then from here, what you're going to do is we're going to have to substitute, right? So let me just say 3 over 5. And therefore, when I substitute 5 over there, where I see t, so I'm going to have 5 over n pi multiply by sine of what? N pi, our t, it is 5, which is our upper bound, divide by 5, subtract, we're going to substitute this one that has 0. So sine 0, because everything's going to be 0. Okay, let's just do it. Minus, what? Okay, we need it. It's fine. Just didn't want to write it, but it's fine. Let's just write it for the sake of clarity. Multiply by sine n pi, then we substitute 0 then. I hope that is, you guys can see that, and then we do our square bracket. So this one is going to fall off because 0 there, sine 0, it's 0. You understand? So that's why I was saying it's not necessary for us to write this, as long as you understand what you're doing. So meaning my bracket basically will end here, but because I just wrote it there, then it was going to be 0 there. And therefore, while we are continuing to determine a sub n, we now have what? We now have 3 over 5. 5 over n pi multiply by sine. Remember, yes?
No, I was calling whatever you are writing.
Oh, I'm sorry. Oh, okay. Thank you. And then, yes, let's go.
N times pi times 5.
Times 5. Thank you. Divide by?
Over 5.
Over 5. Thank you very much. Can I just write it like this? Thank you very much. Now, let's try to simplify this as much as we can. We can see that 5 will cancel 5, and this 5 will most definitely cancel this 5, right? We're going to left with what? Let's multiply everything. We have 3 over n pi sine of what? Of n pi. We close our bracket, which is a sub n. So now, in this case, it will be our a sub n. But this is what I want you to understand. Ne? What I want you to understand is every time when you see pi over here, multiplied by anything, you will always get 0. Okay? Meaning you can prove it with your calculator. You can say pi, you can say sine pi, sine 2 pi, sine 3 pi. But make sure that your calculator, it is in radians. You understand what I'm saying? If you do that on your calculator, you will always get your 0. You understand? So at this point in time, for the fact that we have pi over there, I don't care how much you substitute, even if you substitute 10 million pi, 60,000 million pi, you will always get 0 throughout. So this is n represent any number. So in this point or at this point in time, we can see that our a sub n is going to be equals to 0 because of that pi over there. Therefore, a sub n is equals to 0. Okay, so that's how we go about for this question. Now, what else are we going to do? We are done with this. So the reason is, I understand, maybe someone will be like, but our a sub n is equals to 0. Is it because it's odd or even? I said it's neither, because a sub naught is a number. So for a sub n to be 0 and a sub naught to be 0, that's when we can talk about whether the function it is even or odd. You understand? So here it's neither. When it's neither, you calculate both a sub naught, a sub n, b sub n. You calculate all of them when it is neither. But when it's odd, then that's when you will be that's where you're gonna know whether b sub n is 0 or a sub n is 0. You understand? So please, guys. So now our a sub n, it is 0. Now let's go to determine b sub n. So b sub n is again 1 over L. The integral of our upper bound is L, our lower bound is going to be negative L f at t. Remember, if you forgot how to go about for this equation, as long as you have this one, you will know that when you want to b sub n, you use sign. So that means here you're going to have to multiply by sign. What? N pi t divided by L close the bracket. Oh, dt, because you're integrating in respect to t. Now let us substitute then. We have 1 over, do not forget, it's not 2 over L. It can be 2 over L, I'm emphasizing, when we are working with half-ranged functions. So here it's not a half range. We are writing 1 over L. So we have 1 over L. Half range normally is those who are odd, even, and all of those things. So 1 over L, then we have 1 over 5 over there. The integral of, again, we go back to our function. This is our function. We don't need 0 because we know automatically it's going to give us 0. So I'll just take 3. So meaning function is 3, the lower bound is 0, the upper bound is 5. So the function is 3, the lower bound is 0, the upper bound it is 5. F at t multiply by sine n pi t, remember our L is equals to 5, close the bracket, dt. And therefore, again, let's take 3 outside as our constant. Then we have this. N pi t divided by 5 dt. Now let us integrate this function over here. Now to integrate this function over here, we have 3 over 5. Close the open the bracket. What is the, let me do square bracket. What is the integral of sine? We know it's gonna of sine. We know that it's gonna be cos, right? But it's gonna be which cos? It's gonna be negative cos. So I mean you're gonna have negative. If you forgot, guys, remember it's the final exam. They're gonna give us the formula sheet. So if you forgot how to integrate from sine to cos to avoid making mistake, let us all refer to the sheet. So the integral over there is going to be, we take the reciprocal of the angle, which is 5 over n pi multiply by, cos, multiply by cos of n pi t divided by 5, close this dt. We no longer have dt there because we have already integrated. So square bracket, the upper bound is 5, the lower bound it is most definitely 0. And therefore from here, what you're going to do is we multiply. Okay, I'm going to have 3 over 5. Okay, let me just say negative 3 over 5. There I have 5 over n pi cos of n pi t. Oh, we need to repeat everything. So now we're going to substitute our bounds. We're going to start with this one, which is 5. And then we're going to end with the 0, 1. Divide by 5, subtract what? 5 over n pi cos of n pi. Now we substitute 0 there. It's going to be 0 divided by 5. Close the bracket. Okay. All right. So now let us try to simplify this equation. So we can see that this 5, okay, before we can cancel this 5, let's just wait a bit before we can cancel. I don't want to confuse you. Let's just leave it as it is for now. So we have negative 3 over 5. We have 5 over n pi, and therefore 5 will cancel 5. This side we're going to have cos n pi, close that, minus 5 over n pi, and therefore here everything's going to be 0 because of that 0, right? So when everything it is 0, cos 0 will always give us 1. Cos 0, because this thing, it's going to be affected, the whole thing inside of cos is going to be 0. So cos 0 is going to be 1. So it's going to be 1 multiplied by this. So that means we have 1 over there. I don't have to write it, right? And then square my bracket like this. And therefore, to continue by determining b sub n, I'm going to have, okay, let me take it out first. There's a common factor so that you see it. Let me take it. My common factor is 5 over n pi, 5 over n pi. So when I take 5 over n pi outside there, now I'm going to have cos n pi minus 1. I took it all, I get, and therefore this 5 then will cancel that 5. My answer will be negative 3 over n pi multiplied by cos n pi minus 1. Okay, yes.
I don't understand. Actually, where did you get 1?
This
Minus
one,
1.
this one over here.
Oh, you took out the common factor. Okay. Thank you.
100% yes. So you see, thank you. Yes.
No, not the common factor, but the 1 comes from the cos 0 is equals to 1.
Oh, because I didn't
No,
write it here.
you didn't write.
It's here, that one. It's this multiplied by 1. So I take this side, I take this 5 over n plus pi 5 outside of this bracket, which is here. It's factorizing. Then here I'm going to left with the 1 cos pi. And then here I'm going to left with that 1 over there, which is this. Okay. All right. Thank you. So now, we have what? We have b sub n, right? Now this will be our b sub n. We have a sub naught, we have a sub n, we have this. Basically, this is what we were looking for. We have this, which is this and this and that. L, it is already sorted. So now we can work with this equation, then to expand it. So here they didn't say, hooray, we should expand it to how many harmonics. Maybe we can expand it to 3 and put the dots like ellipses, ta, ta, ta. You understand? Because they never specify to expand this to how many terms, but it's fine. Now to represent this as our final answer, we're going to say that f at t is equals to, let's go back. Remember, our a sub n is 0, is 3. A sub n, a sub naught, it is 3. We're going to substitute 3 over there, meaning we have 3 over 2. Plus, now, remember, this is sum. So this sum, what does that mean? Meaning our n run from 1 to infinity. So we can just write only 3 terms, 1, 2, 3, 3 terms, like expand it to 3 terms, starting from n, which is equals to 1, n is equals to 2, and then n is equals to 3. You understand? Even here we can say, but by the way, because our a sub naught, it is 0, so that means this will fall off. We are not interested on this part for now, obvious, because a sub n is 0, so everything's going to be 0. So here then we left with this part where we have b sub n. We have the equation for b sub n, right? So b1, b sub 1, which is the value of n, because our n, it runs from 1 to infinity. So that means I can quickly determine b1 fast over here. Okay, let me use this space because the equation is this side. b1 is equals to negative 3. We substitute 1 there. We have pi multiply by cos, we substitute 1, there's going to be pi minus 1. So now what is cos pi on your calculator? When you determine cos pi on your calculator, you're going to get -1, right? And make sure that your calculator is in radians, please. So cos pi in this case is going to be negative. Don't punch everything. Do not say -3 over pi. That's why you won't get it right. So just punch this part only. So meaning when you substitute that, we have -3 over pi. Here we're gonna get -2. Why? Because -1, -1, they will give us -2. And then the answer here is gonna be +6 over pi. Let's just leave it as 6 over pi, not in decimals, in what? Therefore, let's determine b sub 2. And then b sub 2, again, we substitute 2 there. So we're gonna have -3 over 2 pi. This, we have cos here, our pi there. I mean, we have 2 pi now, because now where we see n, we substitute 2. We have 2 pi there, close the bracket, -1, and da. I said to you, punch only this portion in your calculator. So when you punch, but again, 2 pi on your calculator, now you're going to get +1. And then when you get +1, this thing is equals to +1. So +1 minus 1 is 0, and everything multiplied by 0, it's going to be 0. So b sub 2 will give us 0. Now let's go to b sub 3. When we want to determine b sub 3, we substitute 3 over there. So we're going to have -3 over 3 multiplied by pi. We have cosine of 3 pi minus 1, close the bracket. Again, we are looking for b sub 3. This will cancel that. Then we're going to have negative what? 1 over pi. For now, we have this, and then inside of the bracket, 3 pi will give us -1. -1, and this -1, they will give us -2. Then b sub 3 will be equals to how much? +2 over pi. Right? So obvious, what will be b sub 4? B sub 4 is going to be 0, because this is a pattern. It's a series. You understand? Yes?
For B sub 1 again, I don't understand how you got -2. -3 over pi times -2.
Okay, let me do this now. Negative, let me check on my calculator, 3 pi. Okay, sorry, what was the question? How did, you don't understand which part?
-2, -2, how did
This
you get
-2.
it? Yeah.
Okay, take your calculator, and then you can punch this thing there. Say cos 3 pi, how much do you get cos 3 pi?
It's -1.
Okay, -1, remember here we're -1. What is -1 in -1? It's going to be -2.
Thank you, sir.
Okay, thank you. All right, so now when we simplify this here, we're going to have 2 over pi, right? Do we need to determine b sub 4? No, because we can see that's a pattern, but you can prove it yourself. When you want to determine b sub 4, you're still going to use this equation, but here you're going to substitute 4 right here. You're going to substitute 4. And then when you substitute 4 here, it's going to be +1, cos 4 pi. It's +1. And that +1 minus this is going to give us 0. The whole thing is going to be 0. So b4 will be 0. So rather would jump to b what? B5. I get we just want only 3 terms. We want 3 terms. So now B5, when we substitute, let me write it here. I don't think I have enough space there. B5, we're gonna get -3 over 5 pi cos 5 pi here. Obvious. We know it's gonna be -2 again, -1. And therefore cos 5 pi is -1. -1, and this -1, they will give us -2. Let me write this one first so that you can see it. They will give us -2. And therefore b sub 5 will then be equals to +6 over 5 pi. So I have 3 terms. I have this term, which is b sub 1. I have this term. I don't need it because it's 0. Leave it there. I have this term, which is b sub 3. I have this term, which is b sub 5. Now I can expand my series, my Fourier series. Remember, this 3 over 2 is from here. And therefore, this part we said it dies. And then now we are expanding this one because we just used the equation for b sub n, right? So what is the first answer? The first answer, B1, we said it's 6 over pi. So we have 6 over pi. Plus, what is the second B? Second B, it is 0, but we don't need it. It's fine. We don't have to write it, but you can write it. And therefore, B sub 3 is how much? It is 2 over pi. So here we have 2 over pi. Plus the third one, we have what? 6 over 5 pi. We have 6 over 5 pi. And therefore, we can say plus ta, 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 because this is to infinity. We don't know how many times do they want. They didn't tell us, so we'll just end it with ellipses to show that the series or the pattern will continue just like so. Therefore, this will be our final answer. Do we all understand how to go about for this question, guys?
Yes, but I have a question.
Yes, ma'am.
Mina, in order for me to know if the function is even, odd, or neither,
Yeah.
I always draw the graph. But if I want a graph, how do you see if it's even or odd or neither?
Let me do it like this. It's number one, having a look at this one, this piecewise function. How do I know it's odd, even, or not? These are the constants. And in my mind, you can even, this one is easy even to draw. I can even draw it in my mind. That's how I can tell. I'll tell you, okay, when it's odd or when it's even, how I'm gonna see again. But okay, this one, how do I see it's neither? It's because I have a constant which is 0. I have a constant which is 3. Literally, this graph is gonna look like this. My constant is 0, this is 0, and then this is positive 3. Right? And then my interval is 0 to 5, 0 to 5, because my period is 10, from 0 to 5, 0 to 5, complete function. So that means it's gonna be, sorry, let me see. I wanna see, this one is from 0 to 5, it's 3. From 0 to 5, it's 3. From 0 to 5, it's 3, meaning it's gonna be here today. Let's say maybe here it's 5. And then 0 is gonna be 5 to negative 5 to 0. Negative 5 to 0 is gonna be here. So meaning this is not the reflection about the y-axis. So we can see by just looking at these functions, but this is simple to draw. But I can see it, I can already imagine it in my mind, or I have the constants. And these constants are not symmetrically placed. There is no equal distance between this or the reflection about, there's no such.
Okay.
Because if it was a reflection, it was going to be like this. If here is 3, this side and this side, this is a proper reflection because this is the image of this S prime. You understand? But look at this. This is down there. This is up there. Yes, this is y-axis. It's more like a reflection about the y-axis. But here we're supposed to have it here, not down there. Even here, we're supposed to have it there. So I can see it's not the reflection about the y-axis. So that means number one is not even.
Okay.
You understand what I'm saying?
Yeah.
Okay, that's how I can see this one. And then the following ones, for an example, if I'm given my function like this and then I'm told, here it's t squared, already I know this is even. Why? Because remember, if I substitute negative t there, and then I substitute negative t there, this is negative, right? And then it's going to give me back my t squared, which is positive, because negative 2. So by just looking at it, I know it's going to times it twice, so it's even. You understand? When I see parabola, I know this is even. There is no way. But if I see something like this, f at t is equal to maybe my t plus 4, for an example, it's a function. I know that here it's odd. Why? Because if I substitute negative f at t there, and then I substitute negative t there plus 4, and then my function will be negative t plus 4, even if I try to make this t positive, but the problem is 4 will be negative. So it doesn't take me back there. It doesn't take me, so I know this is odd. So by just looking at the exponents, those things, I can tell that this function it is odd or even.
Okay.
We will do other question. We will tell, you will tell me maybe whether the function that is coming is odd or even. So, but for now, for here, we are fine, guys. We all understand. No clarity or what, we
Okay.
are fine.
I have a question. I sent
Yeah.
it in the group.
You send it in a group. Okay, no problem. I will look at that question after we are done with this. Is that fine? Okay, that question, it's Laplace. It's this thing. But again, Fourier series.
Fourier. Yes.
I see in the group you sent, let me see, f at x is equals to pi. That's the question. Okay, I see it. Okay, it's fine. Let's do it at the end. Is it fine?
Yes, sir.
Maybe there might be something look similar to this, and you'll be like, ah, man, I can try it then. Then you will just look at my final answer if it's correct or not.
Okay.
No problem. But yeah, I'll be on it when we are done. So now we're gonna jump to question number 2. Now, this type of a question, again, is different. And so I picked these different questions because so that you understand this can be asked differently. Now we are not given in a piecewise. That's the first thing, right? From the first question, it was in a piecewise form, but this one, it is no longer in the piecewise form. That's the first thing. The second thing is that this is the half range. This is the half ranged type of question. Now, Dineo, look at this equation. We want to determine the Fourier cosine expansion of this. They can say cosine, even if they don't say cosine, you should be able to know you're going to determine cosine. Even if they didn't say cosine, they can just say determine the Fourier expansion of this equation. But the first thing is, what I said here, they made your life much more easier. They told you to determine for cosine function because very you're going to get the cosine function only. There is no other way. You understand? So now the reason being why this function, it is even. Why? It's t to the power of 2. It's a parabolic function, right? Which is t to the power of 2. It's even. So when the function is even, b sub naught is now going to be equals to 0. Is that fine?
Yeah.
You can determine b sub naught. You are not wrong, but you will be wasting your time. You get it? All right. And then again, here's the thing that I want to eliminate. So it's fine. So we know how the expansion works, the equation for the expansion works. Okay, we are fine with that part. So now what are we going to determine? Let us firstly talk about t, period. We say t all the time. It's given by 2L. Therefore, the period of this function, you can just take it from here, or you can just take it from this singular interval, which is 2. It's going to be 2. In fact, it's going to be 4. Take it from there, it's going to be 4. So meaning we have 4 over there, which will be equals to 2L. Now, let's solve for L. Divide both sides by 2. Our L will actually be equals to how much? Our L will be equals to 2. I'm saying this type of questions where you have body even, body odd, we are talking about the half-ranged Fourier series. This is not the half-ranged. That's why we were able to tell and then the reason I was emphasizing on these parts. I was emphasizing on these parts. It's very important to take note of that because here, when we want to determine a sub naught, we no longer write 1 over L. Rather, we write 2 over L all the times because this is the half range. You understand? So if I draw this thing on the Cartesian plane, it's going to look like this one cycle between 0 and positive 2, right? It's going to be like how I'm going to have the parabola this side from 0 to 2. It's a parabolic function that moves like this until it ends there to 2. Let me write my 2 there because I expanded it. And then from 0, from here to there, oh, it's parabola, right? From by the period of 2. Again, they just gave us this element already. Our t exists between this 0 and 2, which is included. It's from year to year. But if we were to expand this further, we were going to draw it again over here from 0 to -2. This is the half-ranged function. Okay, so now if this is the case, then we will always write 2 over there instead of 1. Okay, that's the most important thing that we can make mistake about. So here we have L. Please, guys, control your mics.
Hello, like
Oh.
why you did have range?
Why do what?
Have range 2 over L.
Why 2 over L?
Yeah.
Because this graph over here, which is f at t, we say it is half range, ne? So it must be either even or odd. If the function is even or odd, therefore it's a half-ranged function. But if it is neither, therefore it is not a half-ranged function.
Okay, thanks.
100%. So now here we're going to have L, and then here we're going to have negative L, F at t. Remember, we are looking for what? For A sub node. We don't need cos, we don't need sine. We need cos and sine when we have A sub n and B sub n. So I'm saying because this function is even, therefore B sub n is going to be 0. We don't need to waste our time. So now what you're going to do is we have 2 over our L is how much? We said it's 2. We substitute 2 over there, and therefore look at the range. The range is between 0 and 2, meaning our lower bound. And by the way, the range can be given in this notation, can be given in a set builder notation, or it can be given in this notation included because it's a square bracket there, and so I'm writing less than or equal to, and in this side I'm going to less equals to. So we can be given our interval like this, or we can be given our interval like this. This will be the lower bound because it's the lower number. This will be the upper bound because even here, this is the lower bound or the upper bound. So it does not matter how they give us the interval. You just have to understand these intervals. They can be different. So our upper bound, which is 2, our lower bound there, it is 0. Ne? And therefore, f at t, it is t squared, which is our function dt, which is this function f at t. And then now what you're going to do, we again, 2 divided by 2 is 1. Okay, sharp, fine. The integral of t squared. The integral of t squared is going to be 1 over 3 t to the power of 3. Right? Remember, the formula sheet is there. It's exam if you forgot. Okay? It's going to be there. There's no way. And therefore here, what's this? The upper bound is 2. The lower bound is going to be 0. And therefore, now we're going to have what? 1 over 3. Let me take it outside so that I can have t to the power of 3, meaning which is 2. I substitute 2 where I see t to the power of 3 minus, I'm using the bounds, 2 minus 0. So I started with 2. Now I have 0 as my t to the power of 3. Close the bracket. And therefore, I'm going to have 8 there. This is 0. We don't need it anymore. So we have 8 over 3. This will be A sub naught. Now, we need to determine A sub n. So A sub n is going to be equals to 2. It's a half range. Don't forget, divide by L. You see, guys, I'm emphasizing that part. And therefore, because I used to make mistakes there, so I don't want you to be that person as well. So here we have our L. Let's just let's write the equation if we want to remember it. It's fine because we are practicing exam. You don't need it. Remember, A sub n goes with what? Don't confuse. If you are able to remember the Fourier expansion sign, you will always know that A sub n goes with cos. Ne? Cos n pi t divided by L, close the bracket, dt, because we're integrating. And therefore, now we have 2 over 2. The integral of our upper bound is 2. Our lower bound is 0. Our f of t is t squared cos n pi t over L. It's 2 this dt. Now, Here we make a revision from first semester, right? Remember, first semester we're integrating, we're doing direct integration, separable, we're doing all of those things. Here technique is coming, we are integrating, right? Under Fourier series. But the question is, how am I going to integrate these two functions? I have two functions here, which are multiplied together, t squared and cosine. There are two functions. And then, am I going to be able to use the U substitution? You're supposed to know. Am I going to use integration by parts? Because direct integration won't work. It won't work. So meaning we have to use by parts. You understand? We have to use by parts. So now, as a revision as well, so how are we going to use the by parts? I prefer the table one. Guys, table makes our life much more easier. The detail method. So let's go with the detail method. Detail method. Okay, we agree. So remember, the one that comes first, it is the one that we're going to integrate. So we have two functions. We have this is trigonometric function, not trigonometric, algebraic. This is algebraic function, and this is a trigonometric function. This is trig because it's cos. So between a and t, which comes first? Let's go. We have derivative, we have exponential, we have trig. Trig comes first before algebraic. So the trig one, which is cos, it is at the top. So that is the one that we're going to integrate. Always remember, first is for I. I come. I get it when you do English. I table this. I woo this. I is first. You know, that's how I remember these things. You know, you must have a technique to remember these things. So I comes first, right? When you explain something to someone referring to yourself, you come first. So I. So that means the one that comes first is the one that we're going to integrate. So we're going to integrate cos part. So let's draw our table. Okay, I don't need this detailed thing. I'm going to erase it just to create space this side for myself. So I comes first, okay, sharp, fine. So meaning the one that I'm going to integrate, I'm going to write it this side. So what am I going to integrate? I'm going to integrate cos n pi t divided by 2. And then if we integrate this, the other one, we're going to derive it. So here we're going to have t squared. You see? Then we draw up our table. Integration by parts. So here's the rule. Guys, I don't know how, remember, do you know the rules? So if you derive trigonometry, you derive it until you get 0. If you derive trigonometry, you derive it until it repeats itself. If you have deriving exponential, you only derive it once. I don't know if you still remember those rules. But because we have algebraic, t squared is algebra, we're going to derive it until we get 0. But if this side was cosine, let's say maybe the cosine was the one that came after, therefore we derive it until it repeats itself. Like algebra, where if we have cos, we derive it for the first, it goes to sine. We derive it for the second time, it goes to cos, and then we leave it there. But here we're going to derive this until we get 0. Let's see. T squared, derivative of t squared, not integration. Derivative of t squared is going to be how much? Remember, we're going to say, how to derive? We say 2t minus 1 there. And therefore, what is the derivative of 2t? Is going to be 2. What is the derivative of 2? It's going to be 0. That's how we derive. I know, guys, sometimes we can confuse deriving and integrating. So yeah, we just also need to be careful on that. I can also
Are they
do
not
such.
the same?
Integrating, they are reverse. Look, this is t squared. Derive this, it's 2t. Integrate this, it takes you there. It's reverse.
Okay.
Right? Yeah, it's a reverse. Because when you integrate this, you're going to say this is a constant, you take it outside, and then here we have t, and therefore integrate this thing. When we integrate this thing, it's going to be 2. It's going to be integration of t. It's going to be what? 1 over 2t squared. And therefore, this cancels that. Therefore, you're going to left with t squared, which is that one. So yeah, it's a...
Also on the t squared, you differentiate, and then on the other side, you integrate.
Yes. Okay. So meaning, we say derivative. We say, in like integration, it is antiderivative. We have derivative and antiderivative. Antiderivative, it is the same as integrating. Yeah, it's forward and backward. Okay, all right. Sometimes we can confuse integrating and derivatives, so you need to be careful, guys. All right. So now let's come here. What's happening? Oh, integration by parts. Then we're gonna talk about our signs. Ne? Here it's positive, they alternate. We always start with positive. It's positive, negative, positive, negative. They alternate. Ne? And therefore, what is this thing? What is the integration of this? The integration, of course, it's how much. The integration, of course, it's sine. Eh? But remember, we have the angle. We're going to take the reciprocal, which is 2 divided by n pi. Don't write t. And then derivative, of course, is what? It's sine. N pi t over 2. Agree? What is the derivative of this one? I mean, not derivative, integration. What is the integration of this guy? We're going to take the reciprocal of this, multiply it there. So we're going to have 2 multiplied by 2, it will give us 4. And then n multiplied by n, it will give us n squared. Pi multiplied by pi, it will give us pi squared. But this one is going to be negative if I'm not here. Yeah, from sine to cos it's negative, right? Yeah, think so. From sine to cos is negative. We have the formula sheet, guys, if you forgot, please. Okay, don't be a superhero. So here we have cos, negative there. You'll confirm with me if I made mistake there. Pi t over 2, close the bracket. And again, we repeat the same thing. We're going to have 2 multiplied by 4. It's going to be 6, or negative. Let's not forget that it's negative 6 over n squared pi squared. Now cos will change to sine n pi t over 2. Oh, not squared, it's cubed here. N cubed, there's going to be pi cubed. I'm sorry with my writing, guys. But at least I'm talking while I'm writing. Right? Now, remember now what you're going to do from the table. From the table, now we're going to do is we're going to take the diagonals. We're going to multiply the diagonals. And then this one over here, we integrate it. But because we have 0, it's going to die. We won't be able to integrate it. So now that means what we're going to do here is we're going to have 2 over 2 is 1. Right? And then we have the bounds, which is 2 and 0. Let me just put the square bracket there so that we can work with the bounds. And then the integral of this thing, we're going to take it from the table now. We're going to say t squared multiplied by this thing. So we're going to have 2t squared, right, divided by n pi sine n pi t over 2, close the bracket. And therefore, we come to this diagonal. It's a negative there. Negative 2t multiplied by negative 4 over n squared pi. So that means we're going to have positive. Positive 2 multiplied by 4, it will be 8. We're going to have 8t divided by n squared pi squared cos of n pi t over 2. Right? Therefore, we continue again. We take this diagonal, which is positive 2 multiplied by negative 6 over this thing. So positive by positive, automatically we get the negative 2 multiplied by 6. We get 12 divided by n to the power of 3 pi to the power of 3 sine n pi t over 2 square this bracket and square bracket. We can't integrate this because it's 0. At the end, we're going to say integral of this thing, but it's 0. So yeah, and therefore we're going to have the bounds there, which is 2 and 0. Make sure that your integration technique is on point. Remember, EMA2 is all about integrating. Right? Now let's solve this. See what's going to happen. Now, when we substitute our bounds, we start with 2. The 0 part, it is totally out, so I'm not even going to entertain it. But I'm only going to entertain it where I see cos. For sine, yeah, but it's fine. Let's go. So here, when I substitute 2, I substitute 2 everywhere here. Okay, I wanted to do it in some type of way, but yeah, it's fine. Let's just do it. When I substitute 2 over here, um, when I substitute 2 over here, I want you guys to understand, Shame. This is gonna be, I don't have to write it step by step, it's gonna be long. So when I substitute 2 over here, 2 will cancel 2, and therefore you're gonna have sine n pi. You agree with me? Therefore, this is gonna fall off, because remember, sine anything pi, it's basically, you know what, for the fact that we have pi, sine pi here, this is gonna fall down, it's gonna fall off like this, it doesn't exist at all, because we have sine pi there. You get my point? So this it doesn't exist. Even you don't even have to substitute anything, this is out because it's sine pi. So now let's substitute. Yes, come again.
Nothing.
Yeah, for the fact that we have pi here, as long as you see sine pi, I don't care it's sine pi what, as long as there is pi, it's out. And therefore, now let's come here, substitute 2. When you substitute 2 there, we're gonna have what? Again, oh, even this one, it is out because it's sine pi. So our life is simplified. So then now we substitute 2 there. We have, we have 8, our 2 divided by n squared pi squared cos of n pi. We have 2 there, we have 2 there. That's our upper bound. We substituted 2. Now let's substitute the lower bound. The lower bound is 0. So if I substitute 0 here, it's going to be 0. So everything's going to be affected. Even though here we're going to get cos whatever, but everything's going to be affected. So 0 will do nothing here. So now let's go here. We have 8 multiplied by 2, which is going to be 16 over n squared pi squared cos n pi squared. Close the bracket, and therefore this will be a sub n.
So that 0, is it not gonna make that portion 1?
This thing. You are talking about this thing.
When substituting the second last step.
The second last step.
Yeah. Last substitute
This one. This one.
No, the one with 8 into 2. It's actually going to give you 0 because you'll have to substitute 8 multiplied by 0.
Oh.
Yeah,
Oh.
everything will be 0.
Okay. You're talking about this and this.
Yeah.
Yeah. It's gonna be 0.
Okay.
Sine pi, anything, I don't care. As long as I have sine pi. Whether it's sine pi, t, z, y, x, as long as I see pi, that is 0.
Okay.
Not on cos. Cos is different. Cos people are built different. So now, yeah. So our equation for a sub n is 0. Our a sub naught, it is this one over here. That is why the question said determine the Fourier cosine expansion. Just know that the b sine function will automatically give us 0. Even though we calculate it, we're still gonna get 0. So now let us determine our expansion. So we said our, hey, my pen is not moving. We say a sub 0 is equals to 8 over 3. And then we say a sub n is equals to 16 over n squared pi squared cos n pi. So we need to determine the Fourier expansion. So to determine the Fourier expansion, guys, I'm not gonna write the formula. Should I write it or not? T is equals to, remember, a sub 0 over 2 plus sum of n running from 1 to infinity a sub n. Remember, here we have cos. We have cos n. You should know it, n pi t over L plus sigma of n running from 1 to infinity b sub n sine n pi t over L. So this one is 0 because Bn is 0. Now let's go there. So A Sub naught is 8 over 2, so we're going to have 8 over 2, 8 over 3, which is going to be multiplied by these 2. Let's just do it. It's going to be 6. And therefore, plus here, how much are we going to have? We're going to expand. Oh, firstly, we're going to determine A1 and A2 and A3. So did they tell us to how many? They didn't tell us. We will expand it to 3. Let's determine A sub n, A sub 1. So we substitute 1 there, we substitute 1 there, we substitute 1 there. So we're going to have 16 over 1 to the power of 2 is going to be 1. So I have pi squared. And therefore, what is cos pi? Cos pi, I think, is positive 1. Right? See, cos pi.
Cos pi is negative 1.
So yes, it's negative 1, thank you. So cos pi, because we're going to substitute 1 there, is going to be 1 pi. So cos pi is going to give us negative 1. So I mean, this is A1 is going to be negative 16 over pi squared. Now let's go determine A sub 2. A sub 2, we substitute 2 there. So 2 to the power of 2 is going to be how much? We're going to have 16 over 4 pi squared. And therefore, cos 2 pi is going to give us positive 1. Cos 2 pi, because we're going to have to substitute 2 there as well. It's going to give us positive 1. So I will leave it like this. This will be our answer. And therefore, A sub 3, let's just write 3 terms. We substitute 3 there. So what is 3 to the power of 2? It's 9. So we have 16 over 9 pi squared. Cos, what is cos 4 pi? Cos 4 pi is going to be negative. Right? I mean, not 4, 3. Cos 3 pi. Cos 3 pi is going to be negative. So we're going to have negative 16 over this thing. I don't need this part. And therefore, negative 16 over that. And therefore, let's expand this to 3 terms. So when we expand this part, the sum of, we are adding them. So we have this, okay, this positive will be affected by that negative. This positive will be affected by that negative. We're going to have negative 16 over pi squared plus 16 over 4 pi squared plus, okay, this positive will be affected by negative once more again. We're going to have a negative 16 over 9 pi squared plus and so forth. And therefore, this will be our Fourier expansion to infinity.
Oh.
How,
And now you write 16 over pi squared cos n pi t over something. Yo, guys, math.
Oh, this one, you're talking about this one.
Yeah, when you write the final answer name,
Yeah.
that maybe there go an, you write the answer for 16 over pi squared, then you write the cos pi n pi t over L again.
Oh, I see. Nah, no. Yeah, I understand. But now you get it.
You write the answers only like A1, A2, A3.
100%. You don't have to, you'll be wasting your time, and they don't mark that. Even if you look at the memorandums, you will see they don't even write this, they just present their final answer. You understand?
Yeah.
So are we all happy? Mapopa, Sumani,
Yep. Oh.
Lituli, here Mahlangu is happy.
Yes.
Okay. So let us do. So literally, that means your question, you can do it. After looking at this question, your question, you can do it, because your question I saw there is f at x. It's f at x is equals to x, right? It's f at x is equals to x. That's odd. In fact, you will be doing it after doing this question, because this is
Hello,
odd
sir.
function. Yes, yes.
I wanted to ask, can you do that example, the one, the detailed method, one, the one that we're doing now, and then we have to derive a trig function? Because I think if we do that, at the final one, I think we're going to have an integral. So what's going to happen after that?
At the final graph, you're gonna have what?
So let's say we have for derive, we derive a cosine function, right? And then we
Ish.
have to integrate e of x.
Okay, do it. Tell me. There is a part where you have what say effect what. Hey, yeah, in a way, like
So can
yeah,
you write them down? Then I'll tell you.
yeah, yes.
So we're deriving cos of x. Let's just say that.
Ish. I can't hear. Yes.
Background, please.
Okay, no, it's fine. It's fine. We will look at it. It's
Wait,
fine.
can you hear me now?
Yeah,
Can you hear me now?
yeah.
So that detail method, the one that we're doing now,
Mm-hmm.
Ankara, it is a sign, derive, and integrate.
Yeah.
So for deriving, let's derive maybe um, that thing cos of n pi t over 2, and then we integrate e of x. I want to see something.
E of x.
Yeah.
You derive it only once. If it's something like this, you say, for an example,
Yeah.
you use your detail, like D
Yeah.
tail, which comes first. This is exponential. Okay, exponential. This is exponential. It's the one that we're gonna integrate, and then trig, it is the one that we're gonna derive. So trig, we're gonna derive it until we get sign again.
Yeah.
This one we're gonna integrate it forever, which is gonna be the same as this one.
So my thing is, since Velo, we are. Oh wait, we're going to stop at sign, eh? And then we're going to say sign e of a what, then plus the second one, and the third one
Yes.
we're supposed to say plus, and then after include the integral and those values, ne?
Yeah.
And what do we do after that?
And then you see this row over here, you integrate it. So sometimes, if you still do remember from the first semester, there were questions like this, of which we integrate, we do partial what integration 2 times, where we have bomma I is equals to blah 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 blah. Do you still remember those type of questions?
You what?
Remember, sometimes you will be given the function like this, just making an example, a sine, blah, 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 blah. And then when you integrate this, they say integrate this. When you integrate this, you're going to get the same thing again. You're going to integrate, let's say, this thing is going to be equal to ex sine what, plus the integral of the very same thing, which is ex sine. Okay, you know what? We'll do it. It's fine. Hello?
Okay.
Yeah, we will do it. We will do it. It's fine. We will do it.
Yeah, I can hear you. It's fine.
All right, sharp. So let's just complete this one then. All right, that was raised. I think that will also help us guys to go about for this. But now let's start with this one. So now here we have this kind of question. Okay. So now how are we going to go about for this question? To go about for this question, they say to us, determine the Fourier sign. Again, they're telling us sign expansion up to the fourth harmonic. Yeah, it's sign expansion because a sub naught and a sub n, they are both equals to 0. Why? Again, it's the odd function. Look, it's an odd function. When you substitute negative t there, it's going to change the function completely. This is the odd function. So a sub naught and a sub n will give us 0. So that means we're going to have to determine b sub n. But firstly, let us determine the L. We use the period. Now, by looking at this, we say T is equals to 2L. I guess, and therefore our period here, it's going to be how much? It's going to be 10. T is going to be 2 pi. It's going to be 2 pi. So here we're going to have 2 pi is equals to 2L. And therefore, our L over here, it will be pi. Right? Now, let us determine B sub n. B sub n, this is the half-ranged function because it's either odd or even. So here, guys, once more again, we're going to write 2 over L, okay, which is 2. Our L is 2. Don't forget that. The integral of our upper bound, our lower bound, it is 0. Our upper bound, it is pi. Yes, and therefore our f at t, I don't write the equation now because now we are master of this, I get. So we don't have to write f at t dti. We just write f at t as this. We don't want to waste time. Now it's exam. We have pi over 2 minus t. But because it's bn, remember here we have what? Sine. Hence why they say sine expansion. So we have sine of n. Yeah?
Why 2 over 2, not 2 over pi?
Oh, sorry, it's 2 pi. 2 pi, yes. I'm sorry, I didn't see that. It's pi. Oh my God, I'm sorry about that. It's pi. I looked at it from here. It's pi, right? It's pi. Thank you very much. You see, now you see, guys. That was my bad. It's 2 over pi because it's L. Remember, 2 over L, right? Yes, she's correct. And therefore, now we have n pi t, and therefore our L, it's pi. I'm sure I was going to substitute it here, and then I'm going to forget it. Now let's go then. So we have 2 over pi. We have the bound, we have the integral, our bound, it's pi, and then we have 0 there. And therefore here we have pi over 2 minus t this. Now let's go. Pi will cancel pi, and therefore we have sine nt. I forgot dt. I forgot dt here. They will penalize us. I get. So now, at least we're practicing. Imagine if you're in exam. So now, we have two functions that we are multiplying. Again, we are looking at t and t, right? So now what I'm going to do is, we don't even have two. Let's simplify our lives so that we can, we have two, it's fine. We have this function, which is linear function, algebraic, and then we have this function over here. We are multiplying them. And the question is, how are we going to integrate this? Like I said, make sure that your integral skill is on point. We're going to use partial. Can we use, for the fact that we have sine, we can't use substitution. You understand? So we're going to use partial again, integration by parts mean. Now, what comes first? It's trig before this thing, algebraic. Okay, let's prove it. Detail. Okay, trig comes first and algebraic comes after. So meaning this is the one that I'm going to integrate. So I'm going to write it this side. So here I have sine of nt. And then this side, I'm going to have my pi over 2 minus t. Here's our table. Here's our table, right? Right. Now, let's go there. Here we're going to get algebra there. We're going to integrate until we get 0. So what is the integral of, this is a constant, it's going to be 0, it's going to fall off. The integral of t, it's going to be negative 1. The integral of negative 1 is going to be 0. Now, not the integral, the derivative. Now let's integrate. What is the integral of sine t? Integral of sine t, it's going to be
1 over n.
1 over n cos nt. Then what is the integral of this?
It's going to be 1, no, it's going to be, 1 over n squared.
It's not going to be negative.
Negative.
Okay, negative 1 over n squared.
Sine nt.
Thank you very much. You see now. So now here sine will alternate. We start with positive, negative, and positive. Therefore, we take the diagonals, right? This multiply by that, this multiply by that, and this one we integrate. But it's 0 there, everything falls off. Now, let's go to our question to complete it. So here we have 2 over pi square bracket. What is the integral of this? We take it from here. We're going to say this multiply by that. We're going to have What multiply by what? We have pi over 2 minus t multiply by 1 over n cos n t, right? And therefore, we're going to say this multiplied negative by negative is positive. By negative, it's another negative. Negative what? 1 over n squared sine n t square bracket. And then our bounds, we have pi, which is our upper bound. Our lower bound is going to be 0. I hope we are still following. And then from here, what now then are we going to do? We're going to substitute our bounds, I get. So say here we have 2 over pi. Now let's see what's going to happen. Okay, here I see if I substitute pi there, it's going to fall off. Even if I substitute 0 there, it's going to fall off. So this is totally out. Cosine 0, it's 0. So yeah, it is totally out. Now let us substitute pi where we see t, né? Where we see t. So here we're going to have pi over 2 minus pi, close the bracket, and then we have y over n cos of, we see pi there, we have n pi, close the bracket. I get my minus, it's minus from this one. I agree. I substituted pi. Now I'm going to say minus, I'm going to substitute 0. Remember, this one doesn't exist anymore. So I'm left with this part. So I'm using my bounds. So this minus is not this minus. It's minus because I'm using my bounds. Ne? I started with pi, now I substitute 0. So I'm going to say pi over 2 minus 0, 1 over n cos n multiplied by 0. Done. Therefore, let's see how will our mathematics go then. What is 0.5 pi minus pi? We're gonna get, in this bracket, we're gonna get negative 1 over 2 pi, close the bracket. And then this side, we're gonna have 1 over n cos n pi. Right? Hope you agree with me. And then this one over here, we're going to have this. It's going to give us negative pi over 2. And therefore, here it's going to be what? What is cos pi? I mean, cos 0. See? Cos 0 is positive 1. So this thing over here is going to be our positive 1. So positive 1 multiplied by that will give us that we see over there. And therefore, now to continue with this, I'm going to say I have 2 over pi, and then I'm going to take my 1 over 2 pi outside of the bracket. So when I take my half pi outside of the bracket, I'm going to left with negative 1 over n cos n pi minus 1, close the bracket. And therefore, these 2 will cancel that 2. This pi will cancel that pi. And therefore, I'm going to have negative 1 over n cos n pi minus 1. So this is what I'm getting, which is b sub n. Right? Now we're going to determine b1, we're going to determine b2, and b3. Now, how are we going to determine those? We know, we just substitute from that equation. So to get b1, we say it's negative 1 over 1 cos 1 pi minus 1. To get b2, we'll get the answer there. You can give me the answer here. Here we're going to get negative 1 over 2 cos 2 pi minus 1. To get b3, we're going to say negative 1 over 3 cos 3 pi minus 1. What will be the answer over here? What will be the value of B1? Hello? It's gonna be 0 because here it's gonna be, guys, are you there? I'm talking alone.
Yes, we're
Yes.
still punching the calculator.
Oh, but you can look at from here because pi is -1. -1 by -1 will be +1. +1 by -1, this will give us 0.
0.
Okay, and therefore when you substitute 2 pi here, how much do we get?
-3/2.
Come again?
-3/2.
-3/2. -3/2, yeah.
Yeah.
Okay, and then how much do we get?
-2/3.
-2/3. All right, so now I wanna go back. Sometimes we can, just to check, ne, if there is anywhere where we did the mistakes, because mistakes are bound to happen. I get. So now, if we have a look at this, is there maybe where we did our mistake? No, let's revise this to see if there is part or point where we did our mistake. So we took it from here. We multiply this, we said this multiply by that was this, and we said this negative, negative, and negative will give us this. I get, and therefore from here we substitute pi. I said this one is gonna fall out. I get it because it's sine. So sine pi is gonna be out, sine 0 is gonna be out. So we're not gonna focus on this one. Now we're gonna substitute pi here. So when you substitute where we see t, when you substitute pi there, we see t there again. We're gonna substitute pi over here. Okay, fine. Here we're gonna substitute 0 where we see pi. Even here we're gonna substitute 0 where, t where we see t. Sorry. Right. Now, half minus 1, we said is negative half pi, and therefore here we have cos this pi, and then here we're going to have negative pi over that, and then this one over here, when we substitute 0, we said we get +1, right? So I don't see any mistake that we did here. Let's further continue. We take this one outside of the bracket, which is negative pi over 2, negative pi over 2, which is this one. We have 2 over pi there. We cancel this, we cancel pi, we left with 1, and then everything just looks like this, yeah. So far, this is what we get. And therefore, our B1 is this, our B2, we get to be this, B3 is equals to that. So now to determine the expansion, once more again, we're going to say F at T, our A, remember, sub naught is 0, our AN, also it is 0, so we have B. So simple, we can just write these numbers over here. We have 0 plus -3/2, which is -3/2 plus -2/3. So the approach, it matters than the final answer. So I don't know if, because I'm looking at my book, I don't see what's happening, but yeah. Anyways, do we get the whole idea how to go about for this type of questions?
Yes.
Okay. So the idea is to make sure, guys, we understand this more than anything. The basic is important than you're getting it right. So because you don't know how this is gonna be asked in exam. All right, so now let's try to do this one that was sent in a group then. This one that was sent in a group, we have f at x is equals to x. And then our x, the interval for x, it's between 2 pi and the 0. And therefore, our function, the f at x, is equals to x plus 2 pi. I want to ask the person who sent this question. Who sent this question?
Me.
So it's not here pi. Why only 2 pi? Here can be 2 pi and there it can be 2 pi.
I got it in the worksheet.
Okay, here's the thing. This is a half range function. If it's a half range function, I want to show you like here. You see here, our period. What does period mean? I'll explain to you. Our period here. I want to move this thing here. Oh, it doesn't move. Moves. Okay, it moves. So our period here, you see here, we have 2 pi, and then there we have pi. It's like the half of this. Let me go back. You see, even this equation, we have 4 there. This 4 is like the half of this. You see it? Okay, here did they give an interval? Let me check. Yeah, here it's 10. Sorry. Here it's 10, and then there is 5. It's a 5, 5. So that's why we call them the half range function to start with, because they must supposed to have two interval. So when you talk about the period, we talk about complete wavelength. So meaning the interval here at which it is presented is supposed to give us first half and second half, meaning it's supposed to be between x. It's supposed to be between x supposed to be between pi and 0. X supposed to, another one, if maybe it was piecewise, supposed to be between 0 and negative pi. You sure? Like you copied correct in there?
Yeah.
I think that's why you guys were struggling with this. This looks okay to me. But I'm surprised when I see this. Go check all of those questions. You will see. You will always get half of here. If here it's 10, then you get 5. If here it's 20, then you get 10. If here it's 100, then you get 50. Please confirm if you copied correctly first. But then if you copied correctly, if you didn't copy it correctly, then you will see. But if it's like this, we can have questions. We can try to solve it though with this, but I think we're gonna have a problem. Maybe that's why you guys are having problem. But let's try to solve it like this. But please confirm first. It's like that.
Let me check.
Hurry up. Time is not our friend.
Yeah, it's correct.
Okay. Did you check other questions? Do you guys have other questions there?
I have partial. That partial.
No, I mean like questions like this. There are other questions like this, I give.
Okay.
Yeah. You know what I want you to do? I want you to check these numbers and tell me what you see. You will see what I'm talking about. Hence, I am asking there.
I think there was a mistake because he just sent an email for some questions for which he think they're not correct.
Exactly. So the mistake, it's either here, it's 4 it's either here it's 4 pi or there it is 1 pi. One of the two must be compromised here. So yeah, I think you can check all of these Fourier series. They are like that. That's why when you start with the basic, I don't know how guys you went too much on the basic, but that's why when you start to the basic, we look at the period, we look at the half range of that period. For an example, we can even talk about the sine function. Say you are given the sine function just like this, right? And then if you have a look at this sine function, it's a complete one wavelength, which is given by complete cycle, right? This is the half of the cycle, and this is the other half of the cycle, meaning it's a complete wavelength. So from this point to that point, from grade previous high school, you can say 360 degrees, but now here you're saying it's 2 pi. I get inversity, you now call it 2 pi. You use the radians instead of degrees. So now the half of this, which is from here to here, is 180, and then the half of this is going to be another 180, but it's going to end to 360. Or you can say pi to 2 pi. So from here to here is half, from there to there is half. So here as the interval, we represent these halves, meaning from 0 to 180, from 180 to 360, whereby the interval is 180, 180, but the period is 360 degrees. It's given by the complete wavelength. You understand what I'm saying? So this interval, I think this is where there is a mistake. Mistakes are bound to happen even through the questions, not only through the answers only. Is that fine, guys?
Yep.
Yes.
Okay. Okay, guys. Oh, thank you very much. I have class. Let me do this first before you guys leave. So tired, guys. All right.
Wait, you're not done. You still have to explain that detailed method.
Come again.
You still have to explain that detailed method. The one where you're talking about the three functions.
Yo, I can't hear you. I still have to do what?